हम लोग आज इस वीडियो के माध्यम से हाउ टू कैलकुलेट द कटिंग लेंथ ऑफ स्टिरअप की स्टडी करेंगे। 2502 में जो प्रोविजन दिए गए हैं उसके अनुसार कैसे हम कटिंग लेंथ ऑफ स्टिरअप फाइंड आउट करते हैं। देयर आर डिफरेंट थंब रूल्स being used in the field, but those methods may not be correct. Correct method is what is given in the IS 2502. So let us find out how to find out the cutting length of stirrups. Stirrups की कटिंग लेंथ कैसे फाइंड आउट करते हैं उसके बारे में स्टडी करते हैं इस वीडियो के माध्यम से। सो टू फाइंड आउट द कटिंग लेंथ, टेबल 8 में इसका फार्मूला दिया हुआ है 2 टाइम्स ए प्लस ई प्लस 24 टाइम्स डी, जहाँ ए और ई स्ट्रिप्स के इंटरनल डायमेंशंस है। सो फार्मूला इज, कटिंग लेंथ फार्मूला इज 2 टाइम्स ए प्लस ई प्लस 24 टाइम्स diameter of bar. So this is schematic column, and the cross section of the column is 400 by 600. A column is there which cross section is 400 by 600 mm, and cover is 40 mm, and the diameter used in making the stirrup is 10 mm, and the steel of the reinforcement bar is Fe 500. If it is Fe 500, so we know that value of K will be 4 for the bars less than or equal to 25 mm dia, high strength deformed bar. If K value will be 6 for the steel of dia more than 25 mm. So this K is equal to 4 will be utilized in this solving in this calculations. Solving. So let us solve how to find out the stirrup cutting length of stirrup. So A will be 600. This is total depth is 600. Subtract this cover, top and bottom cover, say minus 40 mm, top and bottom cover, and then one diameter at top, one diameter at bottom. So 10 and 10, minus 10 and 10. So internal dimension of stirrup will be 500 mm. And E will be, this is total dimension is 400 mm, minus 2 covers, it will be 40 mm and 40 mm, minus 2 diameter of stirrup bar. So minus 10, this will be 300. So we calculated how much is the internal dimension of the stirrup. It is 500 and A is 500 and E is 300. So let us input these value in the formula. So cutting length formula is 2 times A plus E, plus 24 times diameter of stirrup. So 2 times A plus E, 500 plus 300 plus 24 into 10. So 500, 300, 800 into 2, 1600 plus 240. So it will be 1840 mm. So we require steel of 1840 mm length to make this stirrup. Now how to find out how much length will go in the hooks, in making the hooks in this 1840 mm, how much is the length will be required for making the hook. For this we need to determine hook length, means curved portion and the straight portion of the hook. For this we know the in IS 2502 in table 5 how to calculate the length of bent length of any bar. If it is bent at 90 degree, So formula A plus E minus 1 by R minus D is given. So we find out the bend length, all the three corners, and then straight length, and then further we calculate how to find out the uh, hook portion and the curve portion. So again, this is the stirrup in which there are three bends, one number, three equal bends, one number, two number, three number. Then if we find out this straight portion and this straight portion, and total we subtract from the total cutting length what we had determined already. So we will be finding out the length of this hook portion. So the bend formula for the calculating this bend length at the central line is bend length at the central line is A plus E minus 1 by 2 into R minus D, whereas A और E जो है A and E जो होता है उसका एक्सटर्नल डायमेंशन होता है. तो अब हमारी जो बीम है 600 बाई 400 की है, इसका सेंटर लेंगे तो outer to outer it will be 200 mm, and half of this beam will be 300 mm. So size of the bend will be 300 by 200 less the curve cover. So if this is 200 mm and we subtract the cover of 40 mm, so the length of this bend, horizontal length will be 160 mm. If it is 200 mm, we subtract 40 mm cover, so we find out the one length of this bend, that is 160 mm, and another will be 300 mm less this cover, 40 mm this cover. So we will find out 260 mm. So the bend will be of the size 260 by 160 mm. So let us input this 260 mm plus 160 mm minus half. R is nothing but K into D. R is K into D, where K is 4 and diameter is 10. So R will be 40 mm. So half into 40 mm minus 1 diameter of stirrup. So that is 10 mm. So 260 plus 160, 420 minus 20 minus 10. So this will be 390 mm. If this is 390 mm, then similarly this will be 390 mm, this will be 390 mm. If this is 390 mm, we calculated 390 mm, then this will be 390 mm and this will be 390 mm. Now need to find out the straight portion of the bar, so that if we know this straight portion of the bar and this straight portion of the bar, and whole if we subtract from the cutting length already determined 1840 by formula 2 times A plus C plus 24 times D, we will be getting this hook length, and then further we can determine how much is the curved portion in the hook and how much is the straight portion in the hook. So all this we can calculate very easily. Up now this is 160 mm. We already know this is 160 mm, and this curved portion is K plus 1 times D. We had already studied, and it is given in the IS 2502. The value of this much length will be K plus 1 into D. K is 4 plus 1 into 10. So it will be 40 mm. 4 plus 1 into 10. 5 into 10, so this will be 50 mm, and total length is 160 mm. So if we subtract 50 mm, we get the straight portion of the bend. So this is straight portion 110, which we try here to find out what is the length, straight length before the hook. So that is 110 mm. Similarly, half of the length is 260 mm. Half of the length is 260 mm, and if this is 260 mm, we subtract 50 mm, K plus 1 into K plus 1 times D. this curve portion, that is 50 mm. So we find the straight portion of the this bend, that is 220 mm. This is 220 mm. So total length will be 3 times 390 plus 110 plus 220. So 1170 plus 330, it will be 1170 plus 330 will be 1500. 1170 plus 330, so this is 1500. Now let us find out the curve portion of this hook. So this is 135-degree hook, this is 135-degree hook, and this is the straight portion. So this 135-degree hook we can find out this perimeter of this we can find out by r into theta. R into theta, perimeter of this 135-degree, this 135-degree bend. So R is K KD plus 0.5 D into theta is 135 degree. So convert into the radian, 180. So 4.5 into 10 into pi upon 180 into 135. So solving this we get value 45 into 3.14 into 135 divided by 180. 105.975. We get 105.975 mm. So this perimeter of the bend will be 105.975 mm. So now we need to find out how much is the straight length of this hook. So cutting length we already determined 1840. Cutting length of 3 bends. So this is 390 into 3, so 1170 mm. And we also determined straight length, vertical and horizontal. Straight length, vertical and horizontal, 110 and 220 mm. So 330 mm. So and curve portion we found out this is 105.975. So hook straight portion will be 1840 minus 1170 minus 330 minus 2 times, there will be 2 hooks, there will be 2 curve portion, one from this side and another from this side. So this will be subtracted 2 times. 2 times 105.975. So this will give us the straight portion of 2 number hooks. 1840 minus 1170 minus 330 minus 2 times 106, say 106, so it will be 212 equal to bend length is 128 mm. So 2 number straight portion is 128 mm. So one number will be 128 divided by 2, 64 mm. So this will be 64 mm. So this straight portion will be 64 mm. So now we found out the dimensions. Total cutting length is 1840. This curved portion of this hook is 105, say 106 mm, and this straight portion is 110 mm. This is 220 mm, and this bent length is 390 mm. So 4 times this will be 390, so 1170 mm. So if we take the rod of 1840 and we make bend of 106 mm and another side 106 mm and keep the straight portion of 64 mm, 64 mm, this 64 mm and 64 mm. So a stirrup for the column section 600 by 400 can be very well prepared. This is very important. This may be looking very lengthy procedure, but it is exact and correct procedure, and it doesn't take much time, because if we know the central line method of it, how to find out bend length a plus c, r by minus r by 2 minus d. So we can find out one bend, then multiply by 3, we get the 3 size, then uh, k, we subtract k plus 1 d. So if it depends upon the diameter of the bar, how much will be the subtraction from the bend length, then we find the straight length. And 135-degree bend, it is about 105 mm. So it will be r into theta. So it will again depend upon the diameter of bar. So with that we can get the curved portion and subtract everything from the cutting length, we get the straight portion of the hook. So once we calculate this, this will be very exact method to find out the stirrup length, stirrup cutting length. Thanking you. We will be taking up more videos in coming up based upon the 2502. So this can be noted. Screenshot can be taken for this and this for future reference. Thank you.